All right, welcome to P13. Here, our goal is to graph a polynomial function from factored form. And remember, factored form, that's the one with all the parentheses, right? And we just got done finding zeros and everything with P12. Well, now we're going to kind of put all of that into context. Okay, so first things first, whenever we graph these, there's several key characteristics that we want to find. So I'm going to go ahead and go over, there's some that are going to be repeated, but since we're in factored form, I'm going to go through it. I want you to see how we're looking at this whenever it's in factored form, and then we're going to be able to graph them. All right, so the key characteristics that we need to pay attention to are the leading coefficient, Remember now, this is the number in front of the variable with the highest exponent, but since we're in factored form, this is going to be the number that's in front of all the factors. So this is the number in front of all the factors. And whenever we see an example, this is going to be a little bit more clear, but this is the number that's in front of all the factors that's being multiplied. All right, so the next thing we need to pay attention to is the degree. Well, that's just the largest exponent, right? Right, yeah, but now that we're in factored form, imagine what happened whenever we multiplied all of those factors together, right? If I had 4 factors and I multiplied them all together, I would end up with x to the 4th as my leading term in my degree. So here I'm going to say it's the number of factors and then later on, like if you get to college algebra or ICA, you want to add the exponents. But that's kind of for later on. But for our class, for our purposes, the degree is going to be the number of factors. And remember, if you have something like x times x minus 3 or something like that, these are 2 different ones. So this would be one factor, and here's another factor. All right, so when it comes to degree, we would just add up all the factors, 1, 2. So like if this were the polynomial, this would be a second degree, right? Okay, next, turns. The max number of turns, again, this is the same as it was the last time. This is the degree minus 1. All right, then end behavior. Yeah, this is the same as it was in P11, so use the chart from P11. And when it comes to our zeros, we know how to find the zeros. All right, we're going to set each factor equal to 0. But note, zeros are x-intercepts. What? Yeah, zeros are the same thing as x-intercepts. And I'll go over that here in just a second. And lastly, we look at the y-intercept. And here, we're going to let x equal 0. And, simplify. All right, so we're going to let x equal 0 and simplify. All right. So these are all of the characteristics that we need to find. A lot of them you could just look at it and tell. Leading coefficient, we'll just be able to look at it and tell. Degree, look at it and tell. Turns, once we find the degree, the number of turns is really easy. The end behavior, we're going to have to look at that chart from P11. We have to do a little bit of work when it comes to our zeros, and a little bit of work when it comes to the y-intercept. Other than that, this is actually pretty simple. All right, so let's go over an example here. All right, this is the example that you're going to get on your homework. It's much like an example you'll get on your homework. And these are all of the characteristics that we just discussed. And again, the notes are going to tell you how to find them. This is an example of one of those problems. All right, so the leading coefficient. Now, the leading coefficient, that's the number in front of all the factors. Well, here I have my factors, and the number in front of all those factors is negative 1/2. Okay, no big deal. That's not terrible. The degree, right? Now, here I want you to count the number of factors. How many factors do we have? 1, 2, 3, 4. So this one has a degree of 4. The max number of turns is the degree minus 1, so 4 minus 1 is 3. Now, I want to take a look. I have an even degree and a negative leading coefficient, which means that my arrows are both going to be pointed down. So, on the left side of the graph, right, as x approaches negative infinity, f of x approaches negative infinity. And as x approaches infinity, f of x approaches negative infinity. This, remember, this comes from that chart that we had on P.11. Use your notes. All right. Now, for our zeros, I need to set each one of these factors equal to 0 and solve. So we have x plus 3 equals 0. I have x plus 1 equals 0. I have x minus 2 equals 0. And I have x minus 1 equals 0. And here I'm going to subtract 3. So x equals negative 3. So my first 0 is negative 3. And I subtract 1. X equals negative 1. My next 0 is negative 1. All right, add 2. X equals 2. And add 1. So x equals 1. All right, so my zeros are negative 3, negative 1, 2, and 1. And now for the y-intercept. For the y-intercept, I'm going to replace all of the x's, all of these x's, with 0. And it should make sense. The y-intercept is any point that crosses the y-axis. Well, the x value along the y-axis is 0. So if I plug zeros in for all the x's, and then I simplify, I should be able to get my y-intercept. So let's see what that's going to look like. I'm going to write it like this. F of 0 equals, and it's off the page, but I'm just going to rewrite this whole thing, but instead of x's, I'm going to replace it with 0. So here we go. We got negative 1/2 times 0 plus 3 times 0 plus 1 times 0 minus 2 times 0 minus 1. And now I want to simplify this. I want to make this a little bit more clear. So I get negative 1/2 times 3 times 1 times negative 2 times negative 1. And now I'm just going to multiply these guys. And the 1s are nice, right? So let's take a look. Negative 2 times a negative 1 is a positive 2. 2 times 1 is 2. 2 times 3 is 6. So now I have negative 1/2 times 6. And if you have a fraction times the whole number, turn the whole number into a fraction. And you're going to multiply across the top and across the bottom. Negative 1 times 6 is negative 6. 2 times 1 is 2. And negative 6 divided by 2 is negative 3. So my y-intercept is the point 0, negative 3. Okay? Now, I want to write out some steps here. So, note. Boy, that's funny. I hope somebody laughs at that. All right, so some steps to graph. So the first thing I want to do is I want to plot my zeros. So plot their zeros. The next thing I want to do is plot my y-intercept. So plot the y-intercept. Then I'm going to use end behavior and set my arrows. And finally, I'm going to connect the dots. Okay? So let's see what this looks like. Plotting the zeros. All right, here are my zeros. Remember, zeros are the same thing as x-intercepts. So my first zero is at -3. So -1, -2, -3. Here we go. The next one's at -1 here. The next one's at 2. So 1, 2 here. And at 1 here. These are my zeros. I've plotted my zeros. All right, step 2 says plot the y-intercept. The y-intercept is 0, -3. So 0, 1, 2, 3. So 0, -3 here. And then I want to use my in behavior. Remember, in behavior, so on the left side, it was pointed down. So we're going to have it down, out here. I like to set it just on the outside of the graph. And on the right side, it's pointed down as well. So I'm going to put this arrow down here. Again, just on the outside of the graph. And finally, I need to connect the dots. Now, I want you to know this is smooth and continuous, right? And we have our turns. As I get close to the x-intercept, it's an x-intercept. It goes through and crosses through. Here it's going to go through, cross through. It's going to go through, cross through. Up and over. And sort of got to my arrow out there. Right, everybody knows that's my arrow. And there we go. This is the graph. It's not perfect, it's not great, but this is the graph of our function.